Okay, this is section 7.3 on hyperbolas. So in your flip and fold, you're going to add the information for a vertical hyperbola. The equation is y minus k all squared over a squared minus x minus h all squared over b squared equals 1. So the value a is going to be how many spaces you're going to move up and down from the center, since it's underneath the y. The value b is how much you're going to move left and right, since it's underneath the x. And then on your flip and fold, we created a rectangle from those 4 points, up, down, left, and right. Through the rectangle, you're going to draw the diagonals, which are the asymptotes. So your center is at HK. The vertices are H, K plus or minus A. Since it's vertical, those points are up and down from the center. Your focus points are H, K plus or minus C. This time C is equal to the square root of A squared plus B squared. The focus points are always going to be inside the hyperbola, and it's that distance from the center of the hyperbola, not from the vertices. And then last, your equation for the asymptotes are y minus k equals plus or minus a over b times x minus h. And if you want to, you can go ahead and move the k to the right-hand side of the equation by adding k to both sides. So then it's y equals plus or minus a over b times x minus h plus k. Okay, the horizontal hyperbola is similar. This time the equation is x minus h all squared over a squared, and that should be a minus in the middle. Y minus k squared over b squared equals 1. This one's a horizontal hyperbola because the x squared is first and positive. So same as the last problem, you're going to go 8 spaces or a spaces left and right since it's underneath the x. B spaces up and down since it's underneath the y. You're going to draw a rectangle through those 4 points. Then you're going to draw the diagonals of the rectangle. Those will be the asymptotes. So this time the vertices are going to be the points on the left and right of the box. So that is at h plus or minus a, k. The focus points are going to be h plus or minus c, k. So again, still using c equals the square root of a squared plus b squared. You're going to move c spaces from the center left and right. And the equation for the asymptote this time is y minus k equals plus or minus b over a times x minus h. And you can again move the k to the right-hand side by adding k. Next is the general equation of a conic. So ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So this is the equation in general form, all expanded out. Usually we graph them in vertex form. Sometimes they're given to us in general form. So to identify what type of conic section it is, we need to know the values a and c, and those are the numbers in front of x squared and y squared. If one of them is not there, if there's only an x squared or only a y squared, then that's going to make either a or c equal to 0, and anything times 0 is going to equal 0. So that's why it says a times c equals 0 when it's a parabola. The numbers in front of x squared and y squared are the exact same number, then that makes it a circle. If a and c are both positive or both negative, then that will make it an ellipse. If one is positive and the other is negative, then that's going to make it a hyperbola. So let's look at example 1. We're going to find the center, vertices, focus points, and the equations of the asymptotes and graph. So y squared over 25 minus x squared over 81 equals 1. So we're going to start with the center of the hyperbola. This one is going to be at 0, 0. So I'm going to plot my point 0, 0 for the center. We're going to take the square root of the numbers on the bottom. That's how much left and right, up and down we're going to go. So since 81, the square root of 81 is 9, we're going to go 9 spaces left and right. Square root of 25 is 5, so we're going to go 5 spaces up and down. Once you plot those 4 points, we're going to draw a rectangle, and I'm going to use a dotted line because it's not part of the graph, it's just an aid to help us draw the graph. Then we're going to draw the diagonals of the box, and these represent our asymptotes, and we'll come back and write the equations of those in a little bit. Okay, so the vertices of the hyperbola, since it's y squared first, y squared is positive, this is going to be a vertical hyperbola, and the vertices are those top 2 points, or the top point on the box and the bottom point, which would be 0, 5, and 0, negative 5. Next, we need to find our focus points, so C equals the square root of 81 plus 25. 81 plus 25 is the square root of 106. 106 does not simplify or factor any further, so I'm just going to say that it's approximately 10.3 for graphing purposes. So we're going to go up 10.3 spaces from the center and down 10.3 spaces, and those will be our focus points. So to write those as an ordered pair, since we didn't go left or right any, it's going to be 0, positive square root of 106 and 0, negative square root of 106. Okay, next for the asymptotes, whenever the center is at 0, 0, it makes writing the equation pretty easy. So we're going to start with y equals plus or minus. Then we're going to do the slope of the line of the diagonals. So since these lines go up 5 and over 9, that's going to be plus or minus 5 over 9x. And both of these cross at the origin, which is 0, so I don't need any other numbers in the equation. Okay, then when you draw your hyperbola, make sure that you start at your vertex and you make them as wide as your asymptotes. Okay, so same thing on number 2. We're going to start by finding the center. For this one, it's going to be at negative 3, positive 2. So we're going to take the square root of 144. We're going to go 12 spaces left and right. And the square root of 25 will be 5, so 5 spaces up and down. And draw your rectangle. Then you're going to draw the diagonals of your rectangle. These will be your asymptotes. Since x squared is first in this equation, this makes this a horizontal hyperbola. So your vertices are the points that are on the left and right side of the box. So since we went 12 spaces left and right, you could add 12 and subtract 12 from your center. Those points will be at 9, 2, and negative 15, 2. For the focus, we're going to do the square root of 144 plus 25, which is the square root of 169, which equals 13. So this time we're going to go 13 spaces from the center, left and right. So that's just going to be one more space on either side of our vertex. Those ordered pairs will be at 10, 2 and negative 16, 2. Okay, for the asymptotes of this equation, we're going to start with y equals plus or minus. We're going to do the slope of the line again. So that's up 5 and over 12. Then it's going to be parenthesis x minus 3 plus your k, in this case, would be plus 2. Okay, so then you're going to draw your asymptotes, opening left and right as wide as your asymptotes. Okay, so on number 3, we're going to do the same thing, but this time we're given the general equation, so we're going to have to get it in vertex form. So we're going to start by grouping the x's, then the y's, and then equal the constant on the right-hand side. So I'm going to start with the x's because it's a positive x squared and a negative y squared. So whatever variable is positive, put those first. So 9x squared minus 36x minus y squared minus 6y equals negative 18. Okay, so we're going to look at our x's and we're going to factor out whatever number is in front of x squared, which is a 9. So when I factor out a 9, I'll have 9 times x squared minus 4x, and I'm going to leave a space. And then for the y's, we're going to factor out the negative that's in front of the y squared. So that's going to be minus y squared plus 6y, and I'm going to leave a space, equals negative 18. So we need to complete the square. So we're going to do negative 4 divided by 2 squared, which will be plus 4. And it's really 9 times 4 that I added to this part of the equation, so I'm going to add 36 on the right. Then for the y's, we're going to do 6 divided by 2 squared, which will be plus 9. But really it's a negative 9 that I added. So now we're going to write these as perfect squares. I'm going to keep my 9 out front, and then this is going to be times x minus 2 all squared minus y plus 3 all squared equals 9. Vertex form, we need to equal 1 on the right-hand side. We're going to divide everything by 9. So 9 over 9 is going to simplify to x minus 2 all squared over 1 minus y plus 3 all squared over 9 equals 1. So I'm going to keep this last equation and go to a new slide so I can find and graph this hyperbola. So we're going to start with the center. This time our center is going to be at 2, negative 3. I'm going to take the square root of 1 and go that many spaces left and right, so that's going to be 1 space left and right. Square root of 9 will be 3 spaces up and down. We're going to draw our rectangle and the diagonals of our rectangle. Since x squared is first, this is going to be a horizontal hyperbola. It's going to open left and right. So my vertices are at 1, negative 3, and 3, negative 3. For my focus points, I'm going to do the square root of 9 plus 1, which is the square root of 10. The square root of 10 doesn't simplify, so it's approximately 3.2. So we're going to go 3.2 spaces from the center, left and right. So our focus points are really 2 plus the square root of 10, comma negative 3, and 2 minus the square root of 10, comma negative 3. For my asymptotes this time, we're going to start with y equals plus or minus. The slope is 3 over 1, so I'm just going to put 3 times x minus 2, close parenthesis, minus 3. Okay, then we're going to draw our hyperbola so that it opens as wide as the asymptotes left and right. Okay, the last example, we're going to identify the type of conic section that is given with the general equation. So I'm looking at this equation and I only see one squared term. It just has one y squared, no x squared. So if it either has an x squared or a y squared, that's going to make it a parabola. The second equation, I notice that it does have an x squared and a y squared, and I'm looking at the coefficients of those two terms. One is positive and one is negative, so that's going to make this a hyperbola. C, I have x squared and y squared, and the coefficients are the same number, positive 1, so that makes it a circle. And then the last one, I have an x squared and a y squared. They are both positive. They could have both been negative, and that will make it an ellipse.